In this video, we're going to begin chapter 7, which is about finding confidence intervals. So we're going to start with 7.2, which is about finding confidence intervals for proportions. So here's the kind of question we're going to look at. What percent of adults in the U.S. are in favor of the death penalty? Okay, so let's say a random survey of 500 adults was taken and 55% of them were in favor of the death penalty. Now that sample proportion, that percentage that came from taking a sample, is called the point estimate, or we use the symbol P with a little kind of caret over it. We call that P hat. So that's the percentage that came from the sample. So we want to know, based on this survey, what can we conclude statistically about the entire U.S. adult population? That is, what is the true proportion of adults who are in favor of the death penalty? Now, to be 100% sure of our answer, we'd have to survey every adult. We'd have to take a census and then ask them, are you in favor of the death penalty? And then find that proportion. However, we also know that the sample proportion is an unbiased indicator for the population's proportion. So in chapter 6, we talked about how you can take samples and the proportion is unbiased. So based on the survey, we can say that we're pretty sure that something close to 55% of the U.S. adult population is in favor of the death penalty. So how sure we are is called our confidence level, or our alpha. Well, the alpha is the error, the amount of error in there. So typically, we use 90%, 95%, or 99% for our confidence intervals. So a 90% would be a 10% error, 95 would be a 5% error, and 99 would be a 1% error. So a 95% confidence level means if we took 100 similar surveys about a death penalty, 95 of those surveys would be somewhat close to the actual proportion. Now, what we actually have to do is do this in the long run. We'd actually have to take more than 100 surveys. So we actually want to say in the long run, these surveys would be to about a 95% level where they would have the true proportion. So we're 95% confidence that something close to 55% of the adult U.S. population is in favor of the death penalty. Or we don't know what the actual percent is, but we're 95% sure that it's close to 55%. Now you're probably getting a little frustrated with this wording because we're not saying much yet. We're not being very precise. So what if we say something like we're 95% confident that between 50% and 60% of the adult U.S. population is in favor of the death penalty? But how do we know it's going to be between 50% and 60%? We need to figure out how big it should be. So we're going to go back to thinking about the empirical rule that we learned earlier in the class. So we know that 95% of the possible values in a normal distribution must go about 2 standard deviations from the mean. So we say about 2, but the exact number is 1.96. So close to 2, but not exactly. The exact number of standard deviations we go out from the middle is called the critical value. It's noted as Z alpha over 2, and you'll see that value in your formula sheet. And so these are called the critical values, and these are on your formula sheet so that you can refer to them during tests. They're right over here. And so for a 90% confidence level, the critical value is 1.645. For a 95% confidence level, it's 1.96. And for a 99% confidence level, it's 2.575. So we'll be using those numbers. So how much we're going to go out from the middle to make our confidence level is known as the margin of error. In this little formula, Z alpha over 2 times the square root of P hat Q hat over N is the formula for the error. We'll actually also be able to find this on our calculator. So for our example, to be 95% confidence, so remember p hat was 0.55, q hat is equal to 1 minus p hat, and n being 500, the margin of error would be, so E would be, sorry, I didn't leave enough space there. E would be equal to, so the Z alpha over 2 is based on our confidence level, so 95, we're going to use 1.96. The square root of 0.55, and then 1 minus that would be 0.45 over our N, which was 500. So we would have 1.96 times the square root of 0.55 times 0.45 divided by 500. So we'd get 0.044 if we round to 3 decimal places. So here we'd say about 4.4% is our error that we need to use. So there are two different ways that we can say this. We can say we're 95% confident that 55%, that came from our sample, of the adult U.S. population are in favor of the death penalty with a margin of error of plus or minus 4.4%. Now we can also add and subtract those values. So we can also say that we are 95% confident, and we can take 55 minus 4.4. So that would give us 50.6%, and we could add the 4.4, so 59.4% of the U.S. adults population is in favor of the death penalty. So those are two different ways we can write it. So we can also do the confidence intervals on the graphing calculator. So to find the confidence interval on your graphing calculator, we need 3 pieces of information: X, N, and the confidence level we want to achieve. So to find X, if you have the point estimate, you'll do the percentage times the sample size. So X is p hat times N. And then you do have to round it to a whole number, so you'll round it to the nearest whole number. And then the calculator function we're going to use is called 1-prop Z interval. So to do the problem we just did on the calculator, we're going to go stat over to tests, and we're going to go down, it's letter A, to 1-prop Z interval. Okay, for our X, now here to do 0.55 times 100, we should have done that kind of before. So 0.55 times 500. So there we get 275. So our X is going to be 275. So we're going to have 275. N is the total number, so 500. And we want our confidence level to be 95%, so it's going to be 0.95. And then we're going to hit calculate. And at the top, it gives us our confidence level. So our confidence level here would be 0.50639 up to 0.59361. So this gives us in the form, this would be between 50.6% and 59.4%. To find our E, if you take the upper limit minus p hat, you would get your E. So our E here, we would take 0.59361 minus 0.55. So we would get that our E is 0.04361. So to write our answer in terms of p hat plus or minus E, our p hat was 0.55, so we'd say 0.55 plus or minus the E we found, 0.04361. So number 2 says write the confidence interval from 0.402 to 0.706 in the form p hat plus or minus E. So to find p hat, we're really averaging those two numbers. So we're going to take the lower plus the upper and divide by 2. So to do that here, so to find our p hat on our calculator, make sure you put the lower plus upper in parentheses. So we're going to take 0.402 plus 0.706 in the parentheses and divide by 2. So that gives us our average. Our p hat is 0.554. And just like we talked about above, to find E, you can take the upper minus p hat. So here we would take 0.706 minus 0.554. So 0.152 would be our E. So to write it in the form p hat plus or minus E, we'd have 0.554 plus or minus 0.152. So let's go ahead and do a couple of examples. So number 3 here says, in a recent Gallup poll, 1,025 randomly selected adults were surveyed, and 29% of them said they use the internet for shopping at least a few times each year. Find the 90% confidence interval for all adults. So the 1,025 is our N. Our p hat is 29. So for our calculator, we're going to need X. So for X, we're going to do 0.29 times 1025, which that gives you 297.25 if you do it. We're going to have to round that to just 297. Okay, so we're going to go stat over to tests and then down to A. So our X here is 297. Our N was how many were surveyed. And we want a 90% confidence level. So our interval goes from 0.26645 to 0.31306. So we can say, based on our survey, we are 90% confident that the percentage of people using the internet for shopping is between, if we round here, 27% and 31%. Or we could say, based on our survey, we are 90% confident that 29 RP hat, so 29% of people with an error of, so if we do our upper one, the 30.31306 minus the 0.29, we'd see it's 2.3%. Okay, we'll look at one more here. So it says use the sample data and confidence level to construct the confidence interval for the population P. So here we're going to do stat over to tests, the one prop Z interval. We already have our X, 432. We have our N, which is 800, and we want a 95% confidence level. So our confidence interval will be 0.50546 up to 0.57454. Now in the other form, our p hat is given here, 0.54 minus, and then remember we would do 0.57454 minus 0.54, so we'd get 0.03454, so plus or minus.